Good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up 76 is on the screen. Let's get started, please. And once again, by now, that should be a automatic. It says sketch a bell curve. Use a shortcut formula, no notes. So you should know that automatically by now. And the data given, 28, 5, 15, and 2. I'll give you guys some time. Ready, go. You will need a calculator, so make sure you get one. All right, here we go. Let's get the show on the road. Bell curve. And I need a mean. What'd you get for your mean? Araceli, what'd you get? What is it? 25. Let's see, 20, 30, 40, 50 divided by 5, that's 10. Hands, have you got 10? Okay. Now we need a standard deviation. 1 up, 1 down. That keeps us in the norm. So since we use a shortcut formula, I'm going to use the letter S. All right, what'd you get for the shortcut standard deviation? Pass someone out, Semi. All right, they said Aaron. $7.38. Hands, have you got that? Looks about right. So we are at 17.38 and 2.62. Yes? All right. So, not bad. Copy the agenda, please. Warm-up 76 is done. Intro to probability. Today we're looking at classical versus empirical. And tonight's home play for 4-1, you're looking at exercises 15, 16, 17, and 18. Only 4. Only. You like that, Aaron? I guess we're going to find out. What's that? In a little bit, yeah. All right, so once again, the agenda for today, warm-up 76 done. Intro to probability, we're going to be looking at classical versus empirical. The home play for tonight, it's out of 4-1, numbers 15 through 18. So, only. And I am going to include them. I'm going to include the problems in the presentation. So here's the code. Write this down. LCJZ6. 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 It's going to look something like this. LCJZ6. Oh, yes. We got this. All right. So, our objective for today, can identify and compute the basic probability. We're still doing the introductory portion. We're getting there. But last week, we introduced classical probability. Is that correct? However, I introduced it like this. I said, okay, guys, probability is the chance of an event occurring. And probability has 3 different areas. Tell your neighbor the 3 different areas of probability, please. All right, looks like David's got it. Z's got it. Very good, Z. Mel, I see you, Mel. Mario's got it. Austin's got it. Very good. Go with Brandon Darty. What were the 3 areas of probability that we're going to cover? Woo! Here they are. Classical, empirical, and subjective. Copy that diagram, please, on your notes. So you can have the roadmap as to where we're going. Once again, probability, we're going to be looking at classical, empirical, and subjective. Last week we started with classical. Today we're moving on to empirical. So, of course, by now you know the formula for classical probability. Remind your neighbor the formula without looking at your notes. What is the formula for classical probability? Something, something. Let's go. Mel, what happened in the morning with the announcements? Wow. Oh, yeah. They're like, have a good day, make it a masterpiece, Tiger Pride, and they hung up. I'm like, okay. No, it was Shaw, Mr. Shaw. All right, so did you say P of E equals N of E over N of S? Yes? All right. So today we're moving on to empirical, which means we need a new formula, yeah? Copy it down, please. New formula. P of E equals F over N. By now, you guys should know what F stands for. Tell your neighbor what F stands for without looking up. Yes, frequency. And N is the total frequencies in the distribution or the table. Simple formulas, but they get us where we need to go. Once again, P of E equals F over N. Write that down if you need the description for each piece. It says probability of an event is the frequency of a given class over the total frequencies in the distribution. All right? We good? All right, I'm sending that to your screen so I can move on to the next one. On your notes, I want you to do this. I want you to write classical on the left, empirical on the right, draw a little die in the center. I know some of you are artistically challenged, but try your best. And then come get one die from over here, please. There they are. I'll give you guys some time. Go. All right. So, we're going to start first with classical. Since we already know what to do, we started last week. We went day one. We did an activity with a group with a pair of dice. Remember that? Second day, we actually did not need the dice, and we went straight to what? Remind your neighbor, what did we do straight to what? Day two. We didn't need the dice, but what did we do for that activity? What did we do? All right. Looks like Angelique's got it. Very good, Angelique. Let's go with Austin S. What did we do with the two dice the first day, but the second day we didn't need the dice? What did we do? How? Drawing a table. So let's do that for one dice. Here we go. Draw a table right here. We're going to write outcome. Whoa, that's kind of blurry. Let me rewrite that again. Outcome. All right, and right here we're going to write probability. Probability. All right, so without rolling a die, what would be one outcome? Okay, and then? Bam, Aaron, let's go. Ooh-wee. And fuego. All right. So, let's write our formula next to the classical. We got P of E, focus, by N of E over N of S. So, here we go. I'm going to start with P of 1. P of 1. Let's do this one together. All right. There it is. N of E means how many times that outcome comes up. So let's see. How many times did it come up here in our outcomes? 1. So we write 1 over How many total outcomes, everyone? 6. So therefore, the probability of rolling a 1 is 1 out of 6. Now, do we need the formula for the rest? Because Aaron knows already. So go, Aaron. Let's go. All right. So keep that in mind, guys, in regards to the classical probability. There it is. We're done for classical. For empirical, it's a little bit different. So let's start with a table. Here's our table. Draw a table. Hold your die, please. Outcome. Oh, my goodness. Outcome. However, write F on the right. 1, 2, 3, 4, 5, and 6. Now, before we get started, look up. Look at the two tables. Tell your neighbor what's the major difference that you see from one to the other. What's the major difference? What do you notice major difference, Mario? Yeah, they're both probabilities. However, which means frequency. That means we need to record a frequency. Therefore, this is what I want you to do. You have one die. I'm going to give you 2 songs. Those of you following on YouTube, do the same thing. Play 2 songs. Get a die. Roll it many times. Every time you roll it, you're going to record. You're going to tally what number comes up. You see what I'm saying? So make sure you keep tallying. I'm going to give you plenty of time. You should have close to, I don't know how many rolls. A lot of rolls. Ready? And go. Singing, don't worry about a thing. And stop. Last roll. Okay? So, now, each of you rolled your own die, which means you should have your own numbers. Okay? So here's how it's going to go. Look up. So in your table, you have your tallies. Whatever they may be, right? Okay, so this is what I want you to do. I want you to count each outcome and their frequency and then write that number at the end, whatever that number may be. So for 1, look how many times they came up, count it, and then write your number. For number 2, how many times did it come up? Write your number. Fill those in. Then right now I'm going to use one of your set of datas. I'll pick someone right now. Just give me a second. All right. You have those numbers, yes? All right, so let's see. Help me out, Amelia. How many times did 1 come up? 17. How about 2? 19. 3, bless you. 20. How about 4? 24. How about 5? 12. How about 6? 20. Okay. So now that you have all your numbers, find me the sum of those frequencies. And you're going to find out why. Why, Mr. Q? Because we need a formula for our empirical. Is that correct? Yes? All right. Aaron's going to give me the formula without looking at his notes. P of E what? F over N. That is correct. All right. F over N. So, are we there so far? All right. So what you get for your total, Amelia? $112? All right. So, writing utensils down, look up to the screen. This is how I'm going to use my formula for empirical probability. Y'all ready? Here it goes. I'm going to write my formula here, P of, and I'm going to start with the number 1. What is the outcome? Outcome 1. Okay. Next, how many times did it come up, everyone, according to Amelia's data? 17. And the N stands for the total number of frequencies, or the sum of the frequencies. What is that number? 112. That is correct. Now, can you reduce it? Maybe. However, I want you to use your calculator and find me the decimal equivalent of that. And you're going to do that for each of your data. So, Amelia, what is 17 divided by 112? 0.15? 0.15. All right? So, Amelia, I'm going to walk you through the second one just to make sure that we got the same thing, you and I. It's P of what? This one was P of 1. This is P of 2. And how many total? 19 out of 112. And in decimal form, that is 16. Well, give me the second decimal. 0.16. 169. Okay, I'll leave it like that to the third decimal. All right. All right, so you know what to do. Find me the rest, please. I'll give you some time. Go. All right, Amelia, give me the rest of the decimals. All right, we'll wait a little bit for Amelia. All right, Amelia. P of 3, which is 20 over 12, is 0.178. P of 4, which is 24 over 112, is 0.11. 21. P of 5, which is 12 over 112, that's 0.107. And P of 6, which is 20 over 112, is 0.178. All right? And you guys have your decimals, yes? This is what I want you to do. I want you to add all of those together and see what it gives you approximately. Then I'm going to go around the class and I'm going to ask you for that number. Like that, we can come up with a conclusion to our little experiment that we did right now. I'll give you some time. I'm going to start with Amelia. What was your total, Amelia? Point what? 0.992. Okay. All right. Angelique, what was yours? 0.9. 0.972. Just pay attention. You don't have to write it down. Just keep that in mind. Araceli? 0.998. Awesome T. Your total for the decimals? We'll come back to them. Carter, total? All right. Daly, 0.994. Mia. Oh, okay. Mario, 0.85. Cole. Okay. Logan, 0.999. Sam, 0.993. Vanya, 0.847. Max, 0.997. Z, 0.99. Mel, 0.999. Lulu, what is it? 0.97. Quirin, 1. Ooh. Eshka, 0.997. Alexa, 0.99. Austin S, 1. Biani, 0.97. Aaron, 0.978. All right. Santi, 0.998. David, 0.979. Austin T, 0.997. Carter, 0.96. So, did everybody hear all those numbers? So if you were to be a betting person and someone walked in, some of your colleagues that were absent today, like Cole was absent, so he missed the first part, and our lovely Alessandra is also missing. When they come in, and you're going to tell them, okay, guys, we did an activity with Q yesterday, and it's going to approximately equal to what? What would your bet be? Talk to your neighbor. What would you say? It's going to approximately equal to what? Approximately what? Let's see, enlighten us. Santi. 0.98. Okay. We got a lot of 0.997s though. We got a lot of 0.999s. By the way, what do you think would happen if we get all your numbers and we add them all together? What do you think that's going to approximately be? Everyone. 1. That is correct. All of them are getting closer to 1, aren't they? 0.999, 0.997, 0.994. And the more we roll, guys, the closer it gets to 1. All right. Good observation, yes? So you just experienced both classical versus empirical. However, let's revisit classical. Look up. What do you think this will approximate? Exactly. Also 1. That is correct. All right. So, time to think. Put your thinking cap on. So today we did both. We did classical. Did we roll anything? Did we do anything with a die for classical? No. For empirical, did we do anything? Yes. And remind your neighbor, what is the difference between this table to this table? All right? So therefore, if you were to say a statement, the difference between classical versus empirical, what would you elaborate for your neighbors? Talk to your neighbor. What would you elaborate for that? Talk to your neighbor. What's the difference between classical probability versus empirical probability? Those of you following on YouTube, see if you can come up with your own statement. You should be able to by now. All right. Looks like Aaron's got this. Very good, Aaron. All right. Help us out, Aaron. What would you say? Like you guys say, bruh. Okay, I pass it back to Aaron. What's the difference between classical and empirical probability? What would you say? Okay, but all these also are our probabilities that we computed. These are probabilities. Oh, he's right. For empirical, you have to roll a dice. For classical, we didn't have to go through that. So how would we rephrase that? Let's see, help him out, pass someone. Santi, how would we rephrase that? Okay, versus, but they're both probability. This is a probability as well. Okay. Ooh, Brandon Darty, what do you think? Classical probability. What? No, you guys are coming up with it, not me. I'm trying to just like get that information from you guys. Once again, talk it over your neighbor. Let them know what would you write for classic probability versus empirical probability. Talk it over. You already went through both of them right now in the morning. We did both. One of them we really quick. The other one took some time. All right, looks like Austin's got this. You got it? All right, Aaron says he's got this. All right, Aaron. Classical probability is what? Cannot change the outcome, same thing here, cannot change the what? The probability. The probability, or in parentheses, it is set. It's already set. Okay, I see what he's saying. Comma, empirical probability, what? Did everybody get the same number? Not really. They approximated, but some of you got different numbers, right? So therefore, empirical probability, random chance. And in parentheses, write the word experience. You need to experience the data, whereas the other one, it's already set. One of them's already set, 1 out of 6, 1 out of 6, 1 out of 6, where the other one, you needed to what? Go through the entire experience. Semicolon, and both blank. Tell your neighbor what to fill in. Both blank. Tell your neighbor what to write, please. Both blank. All right, looks like Amelia's got it. Very good, Amelia. Who's hunting? Alexa? Okay, Alexa. And both what? They equal 1. That is correct. Equal to 1. All right? Bring me back my guide, please. We're going to stop right there. Once again, do your home play overnight. You will need to make a table for your home play, and the home play looks something like this. You need a table for 15 and 16, 17 and 18, and is answering questions from a deck of cards. All right? I'll stop right there. Enter your home plate. See you guys tomorrow. Bye.